Picture this, all right? You're sitting right there in the exam chair, staring at the screen, and the clock is just ticking away on your Snowflake COF-C03 exam, and then, bam! You're hit with a scenario that literally strikes fear into the heart of every single data professional out there. A massive data disaster. Someone just accidentally deleted valid rows, dropped a completely crucial table, or ran a terribly bad transformation. Your heart rate spikes. Okay, take a breath. Let's dive into this. Because knowing exactly how to rescue lost data in Snowflake without falling for the exam's carefully laid distractors is absolutely going to save you major points. Welcome to this explanator on the Snowflake Data Disaster Response Plan.
So, here's our emergency response protocol for today. We'll cover 1. The data recovery dilemma, 2. The time travel toolkit, 3. Dodging the UNDRP trap, 4. The fail-safe boundary, and finally, 5. Your exam survival guide.
All right, kicking things off with Section 1, the data recovery dilemma. Okay, here is the exact scenario. Read it carefully on the exam. Valid rows were deleted 2 hours ago. The table still exists. What is your very first action? Now, assume your organization has a retention period of 1 day. In a real-world panic, your gut instinct might be to reach for the biggest red panic button you can find, right? Like submitting a disaster recovery ticket or trying to force some massive system rollback. But listen, the exam is testing your operational logic here. It really wants to know if you can differentiate between normal, user-controlled SQL features and back-end disaster protocols.
So before taking any actual restorative action, you absolutely must confirm your environment. Your very first step, use the foundational diagnostic command show parameters like data_retention_time_in days on that specific table. Why? Well, because you need to verify if the object is actually still safely within the retention window. If your data was deleted just 2 hours ago and your retention period is a full day, this command gives you the green light. It essentially tells you, hey, the historical data hasn't been purged yet, and you are officially empowered to fix this yourself.
Now that we know we can fix it, let's jump to Section 2, the time travel toolkit. Let's look at this specific trio of tools in our time travel combo. And remember, these are all user-controlled, purely SQL-driven actions. First up, you've got the AT or before clauses. These allow you to query the history of an object directly. You're basically looking back in time to inspect the exact previous state before that bad deletion even happened. Second, you have the clone command. This one is absolutely perfect for creating a safe, point-in-time copy of the historical data without overwriting your current working table. And third, there's UNDROP, which honestly acts like a miraculous undo button. But, and this is a big but, you got to be really careful with that last one. Which actually brings us directly to our next point. Moving into Section 3, dodging the UNDROP trap. So the absolutely crucial point here is matching the state of your object to the correct action. It's kind of like a matching game. If your table still exists, but valid rows were deleted, just like in our opening dilemma, you must use the at or before clause to query the data or use clone to copy it. You literally cannot use UNDROP here. I can't stress this enough. Choosing UNDROP when the table still exists is a fatal exam mistake. UNDROP only works if the entire object, we're talking the database, the schema, or the table itself, has been entirely dropped. It restores dropped metadata. It does not put deleted rows back into an existing table. Seriously, keeping this cheat code in your back pocket will save you so much frustration on test day.
All right, Section 4, the fail-safe boundary.
So there is a very hard boundary here you'll want to keep top of mind. On one side, we have time travel. This is your domain. It's user self-service, it's SQL-driven, and you control it 100%. But on the other side, that is fail-safe. Fail-safe is a 7-day Snowflake-managed disaster recovery layer, and it only kicks in after time travel completely expires. It is not a user-operated SQL restore path. Let me repeat that. You cannot write a query to access fail-safe. No way. It actually requires opening a formal support ticket with Snowflake. Because of this, choosing fail-safe as a first step for a normal exam restore task is a guaranteed incorrect answer. It's a massive, massive distractor whenever the question is asking for self-service recovery.
And wrapping up with Section 5, your exam survival guide.
Okay, let's build your exact chronological execution path. Step 1. Always check your attention window first using show parameters. You have to confirm time travel is even available. Step 2.
If the table exists, query the previous state using @ or before to inspect those lost rows. Step 3, once you've found the clean data, use clone to safely copy it, or just insert it right back where it belongs. Now remember, if the prompt actually said the table was dropped entirely, your path would be a bit different. You jump straight to UNDROP. By following these steps in order, you prove to the exam that you truly understand the mechanics of Snowflake recovery and you aren't just memorizing buzzwords.
I want to leave you with this final ironclad rule of thumb to take into the exam room. Inside retention, choose time travel. Failsafe is a distractor. If the disaster happened 2 hours ago and your retention is 1 day, failsafe doesn't even enter the conversation. You are in control. By mastering this boundary, you're not just ready to rescue lost data, you are ready to absolutely dominate this portion of the COF-C03 exam. But it begs a much bigger question. If failsafe isn't yours to control, what is the true cost to your organization if a data disaster goes completely unnoticed past that 1-day retention window?